Hey everybody, welcome to part 5. This is Tom. We're going to talk today about kind of the program loop again, but how to control it a little better. We're going to talk about changing the color of the ellipse moving across the screen, and we're going to get it moving in different directions. But before we do that, let's just go ahead and revise what we did in lesson 4. So we talked about declaring variables and initializing variables, and we talked about different types of variables. So the types of variables are things like float, which we have a float variable here, x, but you also can have ints and character and other things, and we'll use those later on, but right now you don't need to be too concerned with them. Just remember that a floating point variable is any number, positive or negative, that it has a decimal point or doesn't. So let's go ahead and declare another variable. I'm going to declare this y because we're going to use a y variable pretty soon. Now, x and y are different because I've declared and initialized x, meaning I've given x a value, but y I've just declared. So y is actually really useless right now because the program doesn't use it in any way. I've just declared it, but I'm not using it. And a good compiler will tell you you have a variable you're not even using. You just delete it. So let's go ahead and give y a value. We'll call it 50 for right now. And both of these variables, if you remember the word scope, they have scope that is throughout this entire file, meaning I can use x and y inside setup, I can use x and y inside draw, and if I made other functions, I could use x and y in there as well. Now, if I make a variable like a, let's say a in here, and call this 10, I can only see a in this area right here. So from here down to this closing brace, a is not visible inside draw, it's only visible inside here. So that's the idea of scope. Alright, the last thing I talked about was this program loop that you really can't see. It's just kind of this thing in the background and processing, which is always waiting for input from the keyboard or from the mouse. But it also every time uses this draw loop. It calls the draw loop, it calls this function, and then it does everything in here. And it does it a lot of times every second. And we're going to learn to control that in just a minute with something called Framerate. But before we do that, I asked you at the end of last lesson to get the ball moving in the y direction. And so right here, notice I have the variable now. I have a y variable. So let's go ahead and put the y inside here. And then I'm going to make it move in the y direction. So remember, the program loop's going to call this so many times, and you can probably imagine what's going to happen here. So it moves 1 in the x direction, and then it moves 1 in the y direction. So it's going to kind of move downward like this. So it's going to move actually at a 45-degree angle downwards. So this is like this, right down to, and actually since I start at 50-50, it's going to go right off the corner of my screen. Alright, so you don't have to use 1, and since they're floating point numbers, I can change this around and do some other stuff so it doesn't move quite as much. I could also do things like this. I could say this. Okay, and now it's like I get this weird effect where it kind of drops down and speeds up near the end. Notice I'm using x inside this one, and I'm now using this little star, and that means to multiply. So actually this says add onto y whatever x is times 0.02 or 2/100. So it's taking 2% of whatever the value of x is and adding it onto y each time. And because it's multiplying, it's going to kind of accumulate over time because x gets bigger, so the 2% of x is getting larger. If you don't understand what I'm saying, it's okay. The math really isn't that important. It's just important that you know that this star right here is multiply. Now, you can also have parentheses, and you can have pretty much anything you want. You can think of math-wise in here. In processing and in other languages. So most of the time what you see is you see plus, minus, division, times, and then you see this operator, and this one is different across languages. It's this modulus sign. In most languages you'll see percent, and that works just fine. Other languages, they'll write the word mod out, or they'll do something else. But percent sign it's a very unique operator, and you don't really use it too much in a normal class unless you've done modular arithmetic or you've talked about cryptography. But in computers, we actually use it quite a bit, and it's very handy, and I'll talk about it in a lot more detail later on because we're going to use it. But for right now, I just want you to recognize these 5 operators. And when I say operators, I mean anything that can do a mathematical operation of some sort. All right. So let's just leave it what we got right there, and so we have our ball just moving down in a diagonal direction. All right, so looking good. Now I told you just a minute ago we're going to control the looping here, and the program loop goes so many times per second. But what if we want the program loop to go at a fixed time per second that we know of? So we can say frame rate in here. And we can say frame rate of 60. I'm going to say frame rate of 60 just because that's a fairly normal benchmark speed. And I'm going to run this, and you notice it doesn't really change much. Frame rate just says as fast as you can go. I want you to try to go 60 frames per second. So the draw loop gets called 60 times per second. And depending on how fast your computer is, how good it is, you can actually up this to be much larger. So I can do 60,000 times, and the ball just shoots right off the screen. Now, it's probably not drawing 60,000 times per second, but it's trying to draw 60,000 times per second. So really, it's going as fast as my computer can draw it to the screen. So frame rate is really helpful, and I suggest you always set it inside setup just so you know how fast your animation is going, and other calculations can then be adjusted based on that. I don't want you to think of frame rate as something that you're going to want to use anywhere except in setup, meaning don't put it inside draw and change your frame rate based on user input, or don't put it somewhere else and change your frame rate as the program itself is running. It's really not a smart idea. It can become very confusing to get animations correct and different types of stuff in a game correct if you're always changing the frame rate. The better way to do it is to kind of change the speed. So if I want the ball to go slower, I just make both of these less, and then I run it this way. So now the ball is going to go really slow. All right, so just adjust your speed on the things that are moving in the actual animation or product, instead of changing the frame rate. But understand that the frame rate is there, and it's a very handy little function. All right, so let's get some other stuff going now. We want to also be able to change the color of this ellipse, because as we have it, this is really boring. It's a white ball on a black background. And so let's try to change the color, and we're going to use this function called fill. And fill is exactly like background in that it can take one parameter, and that's going to make a shade of gray, or it can take 3 parameters, which this is RGB values once again. Okay, so this RGB value in this case is just red, green, and blue. So we've got a red ball coming down. All right, so that's cool. The other thing you could do with fill is you can actually there's an alpha value to it, and we'll play with that later, but right now we're not going to really worry about it. As well as like different types of coloring, they all seem to have an alpha value, which means you can see things through the background of it. So next, after we fill something, we want to add an outline to it. So I'm going to turn this off, or turn this actually not off, but I'm going to change it to white. This way you can see that my ellipse has a black background, or a black outline. So the inside's red and the outline's black. But you don't always want your things to have an outline like that. So you can use something called stroke, and stroke is another thing that works very similar to fill and to background. So if I change it to this, you're going to see now that my ball has become completely red, which is actually, I think it looks a little bit cleaner, looks a little bit nicer. Alternatively, you can change it so you get a different colored outline. So now I have a ball with a green outline. And I'm going to switch this back now to black so you can better see that green background. Let's go ahead and do that. Background is black, and now you can see it kind of looks yellow because the red and the green blend into yellow. All right. So one more thing. So this, and we can add something called stroke weight. Now stroke weight is going to set the width of the stroke. So if I do 10 pixels, you're going to see that I get a nice fat outline on my ellipse. If I make this a little bit less, maybe 5, tone it down a bit, it's a little more reasonable. Okay, so, and this actually works on every shape. So I can put a rectangle or any other shape in here, and it's going to draw that shape with the same fill, stroke weight that you have. Now the interesting thing is, if you do put another ellipse after this, so I'm going to put one at 100, 100, and I'll make this 50 and 50. And I run this, you're going to notice that this is exactly the same as this one. So if you define a fill, a stroke, and a weight, everything after those functions is going to be drawn using that same fill, stroke, and weight unless you change the values. So if I want to change this ellipse, what I'm going to have to do, let me close that one, is I'm gonna copy these, and then I'm gonna give it its own fill. Let's make this one, I don't know, let's make it blue there. Now let's change the stroke to being red and change the stroke weight to being that. Sorry if you can hear the car horns in the background. I'm pretty high up in this building, but it seems to be that sound carries between all these high rises here. So right now, this one has been changed. So I got a thicker stroke weight on here, and the stroke is red and the fill is blue. So that's how you kind of change colors of things, and we'll be doing that quite a bit as we want to get more interesting animations. And the really cool thing with these is that you can actually change them in the same way that you change everything else. So I can use variables, and for example, I could put X in here. Now X is going to be this value for this ellipse that's moving. And I'm going to change the stroke weight as it moves. So you're going to notice the stroke weight now. It started at 50, and it's adding 0.2 on each time, and you get this really odd effect where it's actually so big that it goes over, it kind of like runs over the boundaries, and then very odd effect. But we could, if we want to see how it expands, we could maybe minus 50 at the start, and now you'll see it come in, and then once it gets past the center, it kind of works its way back out, and then you're just left with should be left with this ellipse 100 by 100 still there, and then there goes my outline. So just kind of play with those and see what you get. We're gonna use the fill and the stroke weight quite a bit to get better looking animations. All right. So the next lesson, right now we just have a ball moving in one direction. We have one ball moving in a 45-degree angle, or whichever way we feel like. What we're going to do next lesson is we're going to get the ball to bounce across the screen. So it's going to hit one wall and it's going to go back. All right. So look forward to that, and I will see you next lesson.